Next, looking at question number 26. Again, if you haven't done it or read it, please pause the video and read the question. So this is an easy question. Now, it's not ideal to consider that the wave is starting from equilibrium at this point. It's actually slightly above the equilibrium point. Though, even if you consider so, you will get the same answer, almost the same answer. So, it's okay, but it's not actually so. We can't be very sure about that. Hence, to measure the period, I prefer to start the measurement from this point. So it starts. I'm going to consider one wave cycle starting from this equilibrium point until this equilibrium point. Now you can see here that the gap here is almost same as the gap here, which means that ultimately one wave cycle is basically 3 centimeters, right? Which means that now since this gap here at the left end and the gap at the right end are almost same, we can shift the entire wave to the right, and you can understand that one wave cycle would be 3 centimeters. Then the work is easy. Now here in the question they say that each millimeter represents 5 microseconds. So the common mistake is you might think of millimeter as centimeter. Be careful, it's millimeter minus 1. So if we try to do it, we have 3 centimeters. 3 centimeters, that means we have 30 millimeters. Each millimeter represents 5 microseconds. So 30 millimeter implies that period is equal to 5 microseconds. So micro is 10 to the power minus 6 times, altogether we have 30 millimeters. So this is equal to 150 times 10 to the power minus 6 seconds. Frequency is equal to 1 over the period. So I need to find 1 over this value. Basically I need to find the inverse of this value. I need to find t to the power minus 1. So you can just use the calculator. I had 150 times 10 to the power minus 6. I want to find the inverse of it. It turns out to be 6666. That now all the values are 67 in the answer, so which means that they have rounded off this to obviously 6700 hertz. 6700 hertz is not there. What is there is 6.7 kilohertz. So common mistakes are omitting the kilo and thinking it is 6.7 hertz, or mistakenly converting this to kilo as 67 hertz. So these were the common mistakes.